Hi guys, welcome to Only Maths Tutorial Point. Today we are starting with chapter 8 of class 10th state syllabus, similar triangles, theorems. So today we are going to start with theorem, that is theorem 8.1, basic proportionality theorem. Very important, or we can call it as BPT or also Thales theorem. So what is a statement? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. I will explain. Take a triangle. If we take a line, okay, if you draw a line, it will meet at two distinct points on a triangle, right? Then this line will be parallel to the base BC. See, once this line is parallel to BC, then this line divides the other two sides, means these two sides in the same ratio. That is the proof, guys. We have to prove. So first write down what is given in the question. In a triangle ABC, DE is parallel to BC. This is the line which is parallel to the base BC, where DE which intersects at the point D, okay, DE which intersects at the point D and DE which intersects at the point E, okay, means this line is touching at two distinct points, that is at point D and at point A on the line segment AB and on the line segment AC, guys. Okay, so required to prove RTP, we need to prove that AD by DB equal to AE by EC, that is AD by DB equal to AE by EC. That one we need to prove. Then see, for proving this triangle, guys, we need to take some construction part, means we need to take some steps in the triangle in that figure, so that then only we can prove the theorem, guys. So this is the figure as per the statement. I have taken this figure as per the statement, but for solving this theorem, we need to take some steps, that is nothing but construction part. Okay, that's why for your easy understanding, I have drawn the figure once again. So I took the triangle till this parallel line is same. Then to prove this theorem, we need to take some steps. Okay, then I join BE and CD line, and also I drawn perpendicular line D to line AC. Therefore this perpendicular meet at a point called M, and similarly I draw a perpendicular EN, okay, on the base AB. Okay, that only I mentioned here. Join CD and join BE and draw DM which is perpendicular to the base AC, and EN, this is the height on the base AB. This height is applicable for any of this triangle, guys. If you consider this side, AB side, this is a height. We can use this height for this triangle and also for this triangle. This is a height we can use on this side. Okay, this height is applicable. We can use as a height for these two triangles, guys. Okay, now coming to the proof. See, for your understanding, I have taken figure once again. See, from the triangle ADE, from the triangle ADE, so what is area of a triangle, guys? What is area of a triangle formula? Half into base into height. So from the triangle ADE, base is AD and height is EN, perpendicular, that only I mentioned here. Therefore from the triangle BDE, see, to prove this theorem, first I took the triangles from one side. Similarly we should solve for this side. Okay, Coming to second triangle, that is BDE. The base is BD and height is same, EN. Okay. Now, taking the ratio of these two triangles, guys, triangle ADE and also area of triangle BDE. Okay. So what we get? We got half into AD into EN by half into BD by EN. We have to take the ratio of these two triangles, that is area of these two triangles. So cancel like terms and we get AD by BD. This one, keep it as equation 1. Equation 1. So similarly, so we proved one side, guys. We proved one side. Now coming to the second side, from the triangle again AED and one more triangle ECD. AED, ECD. So first coming to AED, from the triangle AED, area of triangle nothing but half into base into height, right? So what it becomes? What is base here? AED. Base is AE, height is DM. That only I mentioned here. Half into base is AE, height is DM. Similarly, from the area of triangle CDE. CDE. Base is CE and height is DM. As I said, the height can be used for any of the triangles of same side. Okay. Now, taking the ratio of these two triangles, area of both triangles AED, CDE. Okay. What we get? That is half into AE into DM by half into EC into DM base. So cancel like terms, we get AE by EC. Take it as equation 2. Okay. Now, see, from this figure, what we observe is, from the figure, triangle BDE and CDE are on the same base DE, guys. Okay. From the triangle, see, from the triangle BDE and CDE, these two triangles lying on the same base DE. Okay. These two triangles BDE and CDE lies on the same base DE. That only I mentioned here. DE, where DE is parallel to BC. Where DE is parallel to BC. Okay, this parallel is lying between. Okay, the triangles are lying between these two parallel lines. Yes or no? Therefore, from, take it as equation 3. Therefore, the triangle BDE is equal to CDE. Why equal? Because since these two are parallel lines and these triangles are lying between two parallel lines, therefore the triangles are equal, guys. Therefore, the areas will be same. Okay, that is keep it as equation 3. Therefore, from 1, 2 and 3, from equation 1, 2, 3, we get AD by DB equal to AE by EC. Okay, hence proved, guys. I hope you understand this theorem. So please go through this theorem once again. Okay, for any doubt you can comment me in the comment section. In the next video I am going to explain next theorem. Okay, thank you for watching. Please subscribe to my channel. Thank you.